the deep, silent reaches between the stars, there are worlds that shine with no light. They wander alone, adrift in an eternal night, cut free from the gravity of any sun. Imagine standing on one, above you, a sky darker than ink, unbroken by sunrise or sunset. The cold would be absolute, the silence unending. Yet beneath your feet, oceans could stir, hidden under kilometers of ice, warmed by the slow heartbeat of the planet's core. These are the rogue planets, cosmic exiles numbering perhaps in the trillions, moving through the void like ghost ships across an infinite sea. Each one is a mystery sealed in darkness, carrying the possibility of alien life that has never seen a star. They challenge everything we think we know about where life can exist and how it begins. Tonight, we will journey into their shadowed realms, trace their lonely paths through interstellar space, and uncover the secrets they may hold beneath the frozen skin of eternity. The answers and the questions lie waiting in the dark. Far from the warmth of any star, drifting in the abyss between galaxies, are worlds that shine with no light of their own. They are not tethered by the gentle leash of gravity to a sun. They wander, alone, silent, and cold. We call them rogue planets, cosmic orphans cast adrift in the infinite night. To the naked eye, they are invisible. To the imagination, they are ghost ships sailing through a sea without shores. Yet beneath their frozen exteriors, they may conceal secrets that could rewrite what we believe about life, energy, and survival in the universe. Out there, beyond the familiar constellations, the interstellar void is thought to be empty. But darkness does not mean lifelessness. Rogue planets drift in numbers that may rival the stars themselves. Billions, perhaps trillions, hidden in the gulf between suns. Some are ancient exiles, flung away by the violent birth pangs of their systems. Others are the remnants of shattered worlds, survivors of celestial collisions. Each one is a world without a dawn, locked in eternal night, yet not necessarily without warmth. What lies beneath their icy crusts might surprise us. Deep below the frozen wastelands, internal heat from radioactive decay, or the crushing pressures of a molten core, could keep oceans liquid for billions of years. These secret seas would never see sunlight, but they could still cradle life, alien, resilient, and adapted to a world without a sky. Such a place would be as alien to us as the bottom of an abyssal trench, yet perhaps strangely familiar, echoing the hidden ecosystems of our own Earth. To understand how such hidden warmth is possible, we must look deeper into the heart of these wandering giants. Even without a parent star, many rogue planets retain the primordial heat from their violent birth, energy trapped since their molten youth. Over eons, the slow decay of radioactive elements like uranium and thorium can keep their interiors simmering, much like embers buried deep within a bed of ash. This unseen furnace may be strong enough to melt ice beneath the surface, forming vast subterranean oceans sealed under kilometers of frozen crust. These worlds are often cloaked in thick, insulating shells of rock and ice, a natural blanket that traps heat and shields whatever lies beneath from the hostile vacuum of interstellar space. In some cases, dense atmospheres rich in hydrogen could create a greenhouse effect powerful enough to maintain warmth, even in the absence of sunlight. Such a planet might resemble a colossal pressure cooker, its atmosphere holding in the heat, while the surface remains shrouded in perpetual twilight. We have examples within our own solar system that hint at this possibility. Jupiter's moon Europa and Saturn's moon Enceladus are bathed in ice but hide oceans beneath, sustained by tidal forces and internal heat. Now imagine a world larger than Earth, adrift among the stars, with oceans hundreds of kilometers deep, untouched by light, yet alive with unseen currents. It is a vision that transforms rogue planets from lifeless wanderers into possible cradles of life. If life could exist in such places, it would be life unlike any we know, born in darkness, thriving without the sun's nourishment. On Earth, deep beneath the oceans, there are ecosystems that survive without a single ray of sunlight, drawing energy from chemicals and heat released by hydrothermal vents. Bacteria feed on minerals from the planet's crust, forming the base of a food chain that supports strange and resilient creatures. On a rogue planet, similar processes could occur on a planetary scale, turning its buried oceans into hidden kingdoms of alien biology. These life forms would never know the concept of day or night. Their world would be lit only by the pale glow of thermal vents or the faint bioluminescence of their own bodies. Evolution in such isolation could produce organisms perfectly adapted to extreme pressure, frigid waters, and complete darkness. Without predators from the surface or competition from sunlight-fed ecosystems, life here might evolve slowly, undisturbed, for billions of years, preserving ancient genetic blueprints that on Earth have long vanished. If such life exists, it could be a time capsule from the early universe. Perhaps the first spark of life in the cosmos emerged not under alien suns, but deep within such lightless oceans. And if so, the story of life is not one of clinging to the narrow comfort of a sunlit world, but of enduring in the harshest, loneliest corners of the galaxy. In that case, rogue planets are not just wanderers. They are silent archives, carrying the oldest chapters of biology through the endless dark. But what would it take for us to find one of these elusive worlds, let alone uncover their hidden oceans? Their darkness is their greatest disguise. Without the light of a nearby star, rogue planets reveal themselves only when they pass in front of distant suns, briefly bending and magnifying their light through a phenomenon called gravitational microlensing. To detect them, astronomers must wait for these rare alignments, sometimes lasting only hours, and read the subtle signatures hidden in that bent starlight. Even then, we see only shadows of their existence, mass, size, and distance guessed from the faintest clues. To truly explore them, we would need probes capable of enduring decades or centuries of travel through interstellar space, powered by reactors that never sleep. Such machines would have to navigate with precision, finding a single dark world in an ocean of emptiness, then drill through its icy skin to taste the water below. It would be an odyssey that tests the limits of human engineering and patience. Yet the prize would be profound. The first contact with a rogue planet's ocean could answer one of humanity's oldest questions. Are we alone? Even the detection of simple microbial life beneath that ice would shatter the notion that life requires sunlight and force us to imagine a universe where living worlds drift silently, untethered between the stars. In that moment, the black gulf between galaxies would feel less like a void and more like a bridge. Some rogue planets may hold even stranger surprises, worlds of fire rather than ice. Not all are frozen wanderers. Some are gas giants larger than Jupiter, still glowing faintly from the heat of their formation. These giants, swathed in dense atmospheres of hydrogen and helium, could host moons warmed by tidal forces, much like Jupiter's Io or Saturn's Enceladus, but without the influence of a parent star. Such moons might harbor underground oceans, volcanic plains, or even atmospheres of their own, making them potential havens for life in the cold. In rarer cases, Rogue planets could carry remnants of their original star's warmth within trapped pockets of atmosphere, kept intact by immense gravity. Inside such a greenhouse world, heat could linger for eons, creating strange climates, thick fogs, perpetual storms, and surface temperatures warm enough for liquid water to pool in sheltered valleys. Imagine standing in such a place, a dim sky with no sun, clouds swirling above in eternal twilight, and rivers winding across a shadowed land. These variations remind us that rogue planets are not a single type of world, but an entire class of celestial possibilities. Each carries its own history, a violent ejection from a star system, a slow drift through the void, and an evolution shaped entirely by isolation. In their diversity lies the promise that if we search for life, we must search in forms and places we have never before considered. The universe is far stranger than the narrow sunlight we are used to. Our fascination with rogue planets is not entirely modern. In ancient mythologies, stories of wandering worlds and dark stars appear as omens, celestial bodies that roam without the order of the heavens, harbingers of chaos or change. While these tales were born from imagination rather than science, they echo a truth we now recognize. The cosmos is not a tidy clockwork, but a turbulent sea where worlds can be cast adrift. The myths gave them mystery. Our telescopes give them reality. In the scientific era, it was only in the late 20th century that astronomers began to suspect such planets might exist in vast numbers. Theoretical models of planetary formation suggested that when new star systems take shape, gravitational duels often occur. Larger planets fling smaller ones into exile, much like stones skipping off the surface of a pond. Observations in the decades since, especially through micro-lensing surveys, have confirmed that the galaxy is littered with these drifters, and perhaps there are more of them than stars. This realization has shifted how we think about the ingredients for life. If rogue planets are common, then so too might be the environments they harbor: oceans, atmospheres, volcanic heat sources. Suddenly, life is not confined to the fragile shell of habitable zones around stars. It could be everywhere, hidden under ice, thriving in darkness, evolving in ways we have yet to imagine. And that possibility reshapes the scale of our search for company in the universe. The thought that life might flourish in the endless dark pushes us to rethink our own place in the cosmos. For centuries, we have imagined ourselves as creatures of the sun, bound to its light and warmth for survival. But rogue planets remind us that life's resilience may transcend that dependence. They suggest that biology is not a fragile flame easily extinguished without daylight, but a deep, persistent ember that can glow even in the coldest reaches of space. For humanity, the implications are more than philosophical. If we could learn to harness the same survival strategies that life on rogue planets might use, geothermal energy, chemical synthesis, extreme pressure tolerance, we could extend our reach far beyond the narrow habitable zone. In the distant future, such worlds might even serve as way stations for interstellar travel, offering water, minerals, and shelter in the middle of the void. A drifting planet could become not just a target of study, but a stepping stone. And if one day we do set foot on such a world, the first breath we take will not be of its alien air, but of realization, the recognition that life, in all its stubborn adaptability, refuses to be bound by the boundaries we once believed absolute. In that moment, the silent, starless horizon would no longer feel like exile. It would feel like possibility. But possibility comes with scale, and the scale of rogue planets is staggering. If estimates are correct, There may be trillions of them in our galaxy alone, worlds adrift in the deep, unseen ocean of space. Imagine traveling through that darkness and every few light years passing another hidden sphere, each with its own story written in stone, ice, and fire. The Milky Way could be less an archipelago of stars and more a vast migration of unlit worlds, each one carrying the potential for life or discovery. If humanity ever masters the art of finding and reaching them, our exploration of the universe would change forever. No longer would we leap from star to star. Instead, we could navigate by a map of darkness, charting the paths of planets that move through the void like great whales through an unseen sea. This new frontier would not be bound by the rhythms of suns, but by the slow, deliberate drift of worlds, untethered and eternal. And in that vision, the galaxy becomes something entirely different from what we imagined, a place where the true abundance is not in the lights we can see, but in the shadows we cannot. The empty spaces between the stars may prove to be not a wilderness, but a treasure field, waiting for the moment we have the courage and the means to search its depths. Perhaps that is the greatest lesson rogue planets offer us, that the universe's most profound wonders do not always burn brightly. Some hide in silence, their stories buried under ice and stone, waiting for the rare moment when curiosity dares to uncover them. They remind us that what we cannot see may be more abundant, more varied, and more extraordinary than what we can. One day, our descendants may stand on the frozen surface of such a world, gazing up at a sky with no sun. They may feel the faint tremor of oceans moving far beneath their feet, knowing that somewhere in that darkness, life endures, and in that moment, they will understand that the spark of existence is not fragile. It is relentless, finding a way even in places we once thought impossible. Until that day, rogue planets remain both mystery and promise. They drift beyond the reach of our eyes, yet pull at the imagination like distant tides. And as we search for them, we are not only seeking strange worlds, we are seeking the truth of life itself, hidden in the quiet places between the stars.